Okay, one of the big problems we're going to work with is actually how do we get something into the graphing form? Because when a graph is in standard form, a lot of times we don't have enough information to be able to use it. So graphing form gives us a lot of advantages, like it helps us to figure out what the vertex is, or even to even potentially solve it. So first of all, understanding our forms. The standard form of a parabola is y equals ax squared plus bx plus c. This is a great form if you have to go over and possibly factor it. If you want to use a quadratic formula, you notice the a, b, and c. But when you go to graph this, it's not that easy to graph. So we want to change it to graphing form. Graphing, or also called vertex form, is y equals a times x minus h squared plus k. Now notice, this part's really important. The a's are the same a. These two values are the same. So if I have the standard form of parabola and I wanted the graphing form, I already know my stretching factor. The h and k are not the same as b and c though. In particular, where a lot of students make mistakes, they think k is the same as c, but it's not. So you got to be a little bit careful of that. So let's go over and we're going to look at 3 different methods for going over and changing something from standard form into graphing form. Okay, the first method we're going to look at is the idea of averaging the x-intercepts. So what we're going to do is we're going to take this equation, and this is a good method if it's an easy equation to factor. So this one factors pretty easily. You need 2 numbers that multiply to give me -3, but add to give me -2. So x minus 3, x plus 1. So solving, letting this equals 0. I get x equals 3 and x equals -1. So the actual points are 3, 0 and -1, 0. So graphically, this is what's happening. We have those x-intercepts. Now, if you look at these, halfway between those 2 intercepts, if we went over and imagined, you have a line going across, halfway between my vertex occurs. So halfway between is basically averaging them. So I'm going to add these 2 numbers together and divide by 2. So I do 3 plus -1. That gives me 2, divided by 2 gives me 1. That gives me the x-coordinate of my vertex. Now, I need to find the y-coordinate. And it's real important. We always want to plug back into my original equation. Even though it would still work if I plug in the second one, it's always safest to always plug back into the original equation. So I'm going to do 1 squared minus 2 times 1 minus 3. When I do this, I get 1 minus 2 minus 3, so 1 minus 5 is -4. The y-coordinate then is -4. So that tells me I basically have a parabola that's shifted to the right 1 and then down 4. So my equation is y equals x minus 1 squared. Remember, it's the opposite. First shifts left and right. X minus 1 squared, and then -4. Okay, this one was good. It was easy to do because it was factorable. So what do you do when it's not factorable or it gets a little more complex? That's why we want to look at some other methods. So this time we're going to look at averaging it with a horizontal line. So now we've got a much more complicated equation. This one doesn't factor, it's got a negative in front, it's got all kinds of stuff going on. So this is what the graph actually looks like. Now, most time you're not going to have the graph to be able to reference, so you just can't go over and look at, oh, there's the vertex. I just won't be able to do that. I'm going to have to figure out what the equation is without looking at the graph. Well, just like I could try to find, and I could use quadratic formula and find these x-intercepts. It works. I can average those, but it's going to be really nasty. It's going to be hard. So we want to make something easier. Well, the x-axis is basically a horizontal line. So I'm going to choose a different horizontal line. I'm going to choose the easiest one I could find, which would be using the y-intercept. So if I let y equal 5, I'm looking at where this parabola crosses that horizontal line. So if I find these x values here and here, halfway between is my vertex. So solving this equation. Well, I get 0, I subtract 5 from both sides, equals negative 2x squared minus 8x. And I want to solve this equation. Now I could factor anything else, but maybe you don't want to deal with negatives. So I can multiply both sides by negative 1. Makes it a little bit easier to factor. Well, I could factor out a 2, and I can factor out an x. So I have 2x times x plus 4. Solving, I get either x equals 0 or x equals negative 4. Halfway between x equals 0 and x equals negative 4 is my vertex. So my vertex happens at x equals negative 2. Now I'm going to take this negative 2, and you always go back and you plug it into the original equation. You're going to plug it into each of the x's here. So I get negative 2 times negative 2 squared. So you get negative 2 squared gives you positive 4 times negative 2 will give you negative 8. And I have negative 8 times negative 2, so that's be plus 16 and plus 5, which is going to end up equaling positive 13. So there is my y coordinate. Now I'm ready to put my equation. So that tells me my graph has been shifted to the right, to the left 2 and up 13. So again, we do the opposites for shifts left and right. And then we went up 13. But now I got to figure out my a value. But I told you earlier, we mentioned that the a value is the same. It's negative 2. All I got to do is plug in the negative 2. Now I could go through and try to solve for the a value, but I don't need to. I could just actually look at the equation and I know it's the same value. Okay, let's look at the third method. The third method is completing the square. So what I'm going to do to complete the square, and this time I'm going to give you a graph because this way we couldn't even look at the graph to try to figure out where our vertex was. I'm going to start, I'm going to subtract 7 from both sides. Then I'm going to factor out just 3. I got to get x squared by itself. So when I factor out the 3, I get x squared plus 6x, and I'm leaving a blank spot right here. So to complete the square, what we're going to be doing is you take half of this number here. So half of 6 is 3. I square it, and that's what I'm going to do to complete the square. Because this guy will factor to x plus 3 times x plus 3. It's a perfect square. Well, when I put the plus 9 here, I didn't add 9 to that side. I added 3 times 9. So I added 27 to this side. I got to add 27 to the other side to keep everything balanced. So whatever you do one side of the equation, you've got to do the other. So I added 3 times 9 to the right side. I got to add 3 times 9 to the left side. So y minus 7 plus 27 gives me y plus 20. This part, which we had just mentioned, factors to x plus 3 times x plus 3. So it's x plus 3 squared. We subtract 20. And now we have graphing form. If I want to find my vertex is at negative 3, negative 20. Now you may look at this as, oh, that's really hard. Can I do it the other way? Sure. We can use the idea of the y-intercept again and then average against a horizontal line. Now be careful because the steps are very similar, but they're slightly different. I'm going to let the equation equal 7. Subtract 7 from both sides. And now when I factor this, instead of factoring out 3x, instead of factoring out just the 3, I'm going to actually this time factor out 3x. I want to find out where this equals 0. So what happens when x equals 0? X equals negative 6. My vertex is halfway between 0 and negative 6. So halfway between 0 and negative 6 is negative 3. I take the negative 3, plug it always back into the original equation. I get 3 times negative 3 squared plus 18 times negative 3 plus 7. Well, I'll get negative 3 squared is 9 times 3 is 27. 18 times negative 3 is negative 54 plus 7. That equals negative 20. And I get the exact same equation that we have right here. So the steps are still the same. So you say, okay, that one looks like it's pretty easy. Is there a time when I probably should try to maybe use completing the square, or when the completing square might be a little bit easier? Well, this example is going to show you one where this is pretty easy to complete the square on. And it would be pretty easy also to do the intercept, the idea of just averaging against a horizontal line or letting it equal 17. But this one's actually not too bad. So I'm going to subtract 17 from both sides. There's no number in front of the x squared. So that number in front of it is actually a 1. So I'm going to take half of negative 10. Half of negative 10 is negative 5. I square it, I add 25 to the right side, I add 25 to the left side. Negative 17 plus 25 gives me 8. And again, when I change this to my perfect square, this factors to x minus 5, x minus 5. So it's going to be x and then whatever half that term is. So half of negative 10 is negative 5. Then I have x minus 5 squared minus 8. My vertex then is at 5, negative 8.